Good day. I will be presenting my critique paper on the research titled Characterizing Levels of Reasoning in Graph Theory by Antonio Gonzalez, Ines Gallego Sanchez, Jose Maria Gavilan Izquierdo, and Maria Luz Puertas, and their paper were published 2021. Just a disclaimer, this critique paper aims to assess the strengths, weaknesses, and overall effectiveness of the paper, theory, concept, or argument within the graph. This critique paper breaks down the components, themes, and underlying assumptions present in the research, providing a detailed examination of its entire cases. Also, to offer nuanced interpretations and perspectives on the subject matter, exploring diverse viewpoints and potential implications. Finally, to engage in a thoughtful critique of the subject, highlighting areas of contention, contradiction, or inconsistency while offering constructive feedback or alternative viewpoints. However, this critique paper limits its observation and analysis within the research paper only and do not go beyond what is not written, most especially if it is part of their delimitation of the study. For the purpose of their paper, they have performed a theoretical analysis structured through the processes of reasoning that students activate when solving graph theory problems, which are recognition, use, and formulation of definitions, classifications, and proof. From their process, they have obtained four levels of reasoning where it became their basis for discussion. In this kind of papers that has something to do with graph theory, discrete mathematics is not far behind the concept of this, which the researchers found an importance. That is why they included the definition of discrete mathematics, its concepts related to graph theory, and then the justification on how they came up with their study. The researchers have developed a model for learning of graph theory through a theoretical analysis, which is the starting in the creation of the many educational models. Here, they found out that the level 1 students clearly just do the basic things in recognizing, defining up to proving. For level 1, they recognize the graph by just merely visual appearance. For definitions, they define it where it does not require any knowledge of graph theory. For formulation of definition, through visual descriptions. For classifications, through partition. And for proof, they check in a specific representation of the graph. They presented that as the level is getting higher, the process are getting complicated. For level 4, they recognize the graph through formal mathematics where they define it through accepting equivalent definitions. They classify it as both partitional and hierarchical, and in terms of proof, they use formal proof. The difference of level 1 up to level 4 is very visible in the different processes. In conclusion, they have characterized level of reasoning in graph theory by extending the Van Hale model to the field of mathematics. Their study addresses a research problem that is relevant in mathematics education to extend a theoretical framework to learning a mathematical objects that had never been studied from this approach. For the critical analysis, the researchers established enough rationale for their paper to be one of the few contributory researches, articles, and dissertation when it comes to graph theory. It is very clear from the start that they want to contribute research that has something to do with graph theory, and it has something to do with education. The researchers have established a strong foundation of their literature review where they highlighted the work of Hazan and Hadar in 2005 about the understanding of university students from the perspective of the deduction of the level of abstraction. Since it has something to do with students, this review of literature is very essential in their study. From reading also of the researchers, they provided the fundamentals of graph theory that focuses on the basic notions of graph theory by Biggs in 2002, which they use in presenting their learning model. Of course, the study of graph theory embedded in a research will not be complete without the discussion of its basics, and that is present on their paper and that is commendable on the researcher's part. It is also important that in the last part of their literature review, they have presented the global and local properties which is very necessary in their study. Personally, while reading the paper of Gonzalez et al. 2001, they have lots of input, most especially on their review of related literature. It is very evident also that in their paper, they have groups literature that have the same thoughts and another group for those literature that talks about different aspects. The establishment of their introduction and literature review gave a great catch to the readers to continue reading their paper because of how well it was written. For their methodology, they have developed first a model for learning of graph theory through theoretical analysis, which serve as the starting point in the creation process of many educational models of Jaime and Gutierrez 1990. It is important that their model will be developed first before the conduct of their study. Their theoretical framework helped the researchers establish their framework for the conduct of their study, where their work provides an initial characterization of the Van Hill levels for graph theory in order to guarantee accuracy, and based on the prior research on students' mathematical thinking, researchers' mathematical understanding of the concept of graph, as researchers in mathematics and didactics of mathematics, and their experience as graph theory teachers. For the result of their study, they have used the Van Hill levels for learning graph theory that they have proposed. What is evident on their paper is that each subsection is devoted to describing the evolution of each process of reasoning along levels. I think the strategy is very much easier to understand and presented to the readers of their study. The researchers then specified on their paper each process of reasoning, its corresponding meaning in the context of learning graph theory. From these identified processes, they then discuss the different learning approaches and performance of each level of students. The researchers made use of the same illustration and see how the four levels give their observation, discussion, and analysis of the figure, where they use the six-vertex cycle. The strategy of this by the researcher is, I think, a great idea for comparison. They were all given the same figure, where the different levels may give the same answer. However, the higher level might give a more complex analysis of the figure. These were very evident on the different subsection that they have synthesized from the response of the students. Here is the figure 1, the 6-vertex cycle, where there are 4 figures given. They started with recognition. With the 4 levels, they emphasize how the level 1 students recognize the graph by its visual appearance, including the vertices and edge, but beyond that, there are no other observation. This observation was compared to how the higher levels recognize the graph, where they go beyond the edges and vertices. As the level increases, the more recognition of the graph were being emphasized, and there are many recognitions from the level that were not present in level 3 to level 1. The researchers used the same pattern in discussing the different subscription, like the use of definitions, the formulation of definitions, the classifications, and proof. In this way, the different levels were compared and contrasted, and the proper observation were given. In here, you can really see how advanced the level 4 students compared to the level 1 students. Level 1 is somewhat close to level 2, level 2 to level 3, and level 3 to level 4. Their answers for the different subscriptions reflect their level as a student of graph theory. It is commendable that the researchers dug an in-depth analysis of these figures using the different levels of the students. One of the most crucial part of the researchers presented was on how the different levels has shown their proof for the proving part. In mathematics, we all know that proving is one of the hardest part, and in proving, the different levels have their own way of proving. In the research, level 1 students verify properties in particular presentation instead of exploring others. Level 2 already can identify local properties and global properties that they can use for proving. As for level 3, they can produce informal proofs that requires few logical steps and or are obtained from the observation of examples. And finally, level 4 students can elaborate formal proof with several logical steps thanks to their advanced skills. So, for a reflection as a teacher, I think knowing the level of your students really helps on how you can start your teaching. And this research by Gonzalez et al. Is very useful for all teachers of graph theory to recognize levels of their students. As shown in their paper, the levels of reasoning that they have proposed for graph follows the same structure as other proposals under Optic of Van Hale model for a variety of mathematical concepts. The table presented in Table 1 that talks about descriptors of each processes of reasoning in graph theory at each level is very useful for readers to understand more about their research. And of course, to understand the ability and skills of the students who belong to the different levels. It is wise to note also that the researchers pointed out great skills for each level that is not present to other levels, most especially level 1. Where in Notion, we think that they are just simple, but with this study, there are many skills that level 1 possess than the higher level should learn from. Personally, I found that their research is very timely, most especially in the field of mathematics. Graph theory is becoming common to the curriculum like for grade 9 in the Department of Education and for the subject in college like mathematics in the modern world. As far as the teacher wanted to teach the lesson with the skills, it is important to note also that in learning graph theory, there are many levels that the teacher should recognize. For those instructors or professors teaching the graph theory subject itself, this research will help them understand the students more on how they recognize, they use the definition, they formulate the definition, the classifications and proof from their different level. For my takeaways, I learned a lot from this research. I find graph theory fun and interesting, but not all students do have the ability to have fun in the subject because of how the teacher treated all the students in the same level. This research gave an eye-opener that students should be treated basing on their level, but they should not disregard that level 1 has some skills that are better than those students in level 4 and vice versa. For my suggestion, the researcher or maybe the future researchers may test the level of knowledge of these students from different levels by identifying the different concept in graph theory. In this way, they might see also when it comes to skills, level 1 might be more knowledgeable in some areas where the notion is level 3 and level 4 should have been the highest. Overall, their paper is very relevant. So that's all, and that's how I critique this paper. Thank you.